Okay, so here we go again. So first we're starting with calculate the following factorials. What is a factorial? Well, 11 factorial is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 8 factorial, so 11 factorial divided by 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What's the division problem? So stuff's same on top and bottom. I can cancel it off. So the ones go away, twos go away, the threes go away, fours go away, fives go away, six goes away, seven goes away, eight goes away. Just so we're clear, this is a division problem. So if I've got an 8 on top and an 8 on bottom, that's 8 divided by 8, that's 1. 7 divided by 7, that's 1. 6 divided by 6, that's 1. And these are being multiplied, so that's 11 times 10 times 9, and then I got a bunch of ones. Well, the ones don't change anything. So that means I'm going to have 11 times 10 times 9, or 90 times 11, which is 990. Bada boom, bada bing. So over here, I've got 12 factorial divided by 9 factorial times 3 factorial. So that's 12 times 11 times 10 times 9 factorial divided by 9 factorial times 3 times 2 times 1. Now, the reason I stopped at 9 factorial is just because, look, top and bottom, I've got 9 factorial. What is 9 factorial? Well, that's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, what's the use of writing that all out, both top and bottom, if I've got 9 factorial on the top and 9 factorial on the bottom? They're going to cancel each other off. So I don't need to write them both out. I can just, okay, they go away. So what do I got left? I've got 12 times 11 times 10 divided by 3 times 2 times 1. Well, that's 12 times 11 times 10 divided by 6. So I can divide by 6 on top and bottom. The 6's cancel each other off, I get 1. Well, I've got 12 on the top, so 12 divided by 6 is 2. So now I'm going to have 2 times 11 times 10 over 1, which the 1 falls off. So then that's just 22 divided by 10, so that's 220. Boom. Now, determining the number of possible solutions for a polynomial. There's two things I need to look at. I need to look at the coefficient of the leading term and the constant of my coefficient. So the constant I'm going to call P, and the leading coefficient I'm going to call Q. So I'm looking at P and Q. Well, if I move this stuff out the way, the P is 3, and the leading coefficient Q is 1. So now I'm going to look at the factors of 3. So the factors are just what numbers multiply to give me 3. Well, that's easy. Plus and minus 3, plus and minus 1. And then I'm going to look at the factors for Q. Well, that's just plus or minus 1. So now what I do is I end up making ratios with these to see how many possible solutions I have. So I got, I've got plus or minus 3 over plus or minus 1. And I have plus or minus 1 over plus or minus 1. So plus or minus 3 over plus or minus 1. So that's 3. That's 3 over 1 and negative 3 over 1. And then plus or minus 1 over, that's 1 or negative 1. So that's a possible 4. Well, that's 4 possible solutions. I could have 3, negative 3, 1, and negative 1. See, I'm looking for duplicates. And so, there's only so many. So maybe it'll become, hopefully, well, not maybe, but hopefully it'll come plainer when we look at the second one. So let's look at my P and my Q. Well, my P is 24 and my Q is 2. So I'm going to put together all the factors of 24. So that's plus or minus 24. That's plus or minus 12. That's plus or minus 8. That's plus or minus 6. That's plus or minus 4. Plus or minus 3. That's plus or minus 2. And then plus or minus 1. And I ran out of room, so let me write them again. Let's write them just a tad bit smaller. So that's plus or minus 24, plus or minus 12, plus or minus 8, because 8 times 3 is 24. Plus or minus 6, plus or minus 4, because 6 times 4 is 24. Plus or minus 3, plus or minus 2, and plus or minus 1. Those are all the factors of 24. And then I look at all the factors of 2. That's plus or minus 2, plus or minus 1. So now I'm going to build ratios with all of these. Now when I do, there's definitely going to be some duplicates, so I need to watch for that. So let's start with the 2's. So I've got 24, plus or minus 24, and plus or minus 2. So plus or minus 24 over plus or minus 2. I've got plus or minus 12 over plus or minus 2. I've got plus or minus 8 over plus or minus 2. Plus or minus 6 over plus or minus 2. Plus or minus 4 over plus or minus 2. Plus or minus 3 over plus or minus 2. Plus or minus 2 over plus or minus 2. And plus or minus 1 over plus or minus 2. So plus or minus 24 over plus or minus 2, that's either positive or negative 12. Plus or minus 12 over plus or minus 2, that's plus or minus 6. Plus or minus 8 over plus or minus 2, that's plus or minus 4. Plus or minus 6 over plus or minus 2, that's plus or minus 3. Plus or minus 4 over plus or minus 2, that is just plus or minus 2. So let's keep going, plus or minus 2. And then plus or minus 3 over plus or minus 2, well, that's just plus or minus 3 over 2. Plus or minus 2 over plus or minus 2, that's plus or minus 1. And then I've got plus or minus 1 over plus or minus 2, that's plus or minus 1/2. So now that was this one. Matter of fact, let's highlight. So that was this one. All of those first numbers over that one. Now let's put all of those first numbers over the second one. Let's do that in red. So I'm going to have plus or minus 24 over plus or minus 1. I'm going to have plus or minus 12 over plus or minus 1. I'm going to have plus or minus 8 over plus or minus 1. Plus or minus 6 over plus or minus 1. Plus or minus 4 over plus or minus 1. Plus or minus 3 over plus or minus 1. Plus or minus 2 over plus or minus 1. And plus or minus 1 over plus or minus 1. So what is that? Well, that's plus or minus 24. 12, well, that's plus or minus 12. That's plus or minus 8. That's plus or minus 6. Because remember, I'm just dividing by 1. 24 divided by 1. Plus or minus 4. Plus or minus 3. Plus or minus 2. Plus or minus 1. So now I'm going to highlight those two. I'm going to look at the green. And I'm going to look at the blue. Maybe not blue. How about we do purple? Okay, so purple. All right, so I'm looking for duplicates. I've got 12 and 24. Okay, so I'm going to start circling with black. So I got plus or minus 12, plus or minus 24. Well, there's 12 again, so I don't need to write it twice. I got plus or minus 6, plus or minus 8. plus or minus 4, plus or minus 6, don't need to write that again. Plus or minus 3, okay, I don't need to write plus or minus 4 because I already got it. Plus or minus 2, yep. Plus or minus 3, nope, already got it. Plus or minus 3 over 2, that's different. Plus or minus 2, nope, already got it. Plus or minus 1, oh, already got 1. So then the last is plus or minus a half. So each one of these circles is representing of two values because it's the plus 12 or the minus 12, the plus 24 or the minus 24. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's possible 20 solutions. So that's how you do that. I look at the factors for my constant divided by the factors of my leading coefficient. And then I just eliminate the duplicates. So that's that. All right. This next thing is a little intense, but not really. It's just a matter of remembering a couple rules. I'm going to give ourselves some more space. So let's see. Find the coefficient of x squared of 1 plus 4x to the 6th power. So 6th power. First thing, let's remember Pascal's triangle. Remember what my coefficients, my basic coefficients are. Starts off at 1, then I've got 1 and 1, then I've got 1, 2 and 1, then I've got 1, 3, 3 and 1, then I've got 1, 4, 6, 4 and 1, then I have 1, 5, 10, 10, 5 and 1, and then I've got 1, 6, 15, 20, 15, 6 and 1. So that's the row I'm looking at. Is this the row for the 6th power? That's the 6th row. I mean, technically 1, 2, 3, 4, 5, 6, 7. Technically 7 row, but where's I don't say is n equals 6. Okay. So my general setup would be 1 times a to the 6th power, b to the 0 power. This is my a, this is my b, plus 6th, a to the 5th power, b to the 1st power, plus 15, a to the 4th power, b to the 2nd power, plus 20, a to the 3rd power, b to the 3rd power, plus 15, a to the 2nd power, b to the 4th power, plus 6, a to the 1st power, b to the 5th power, plus 1 times a to the 0 power, b to the 6th power. Now look at what happens with these exponents. So the first one is going to be this first thing to the 6th power, but because it's to the 6th power, there's not going to be anything there because the exponent always adds up to 6. So 6 plus 0, 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, 1 plus 5, 0 plus 6. So now, if I'm thinking like this, I'm just going to plug and chug these values. Now I'm looking for x squared. So as soon as I find x squared, I can stop. So I've got 1 times a to the 6th power. So that's just 1 to the 6th power. And then b to the 0. Anything to the 0 is just 1. So that's not going to matter. So next, I've got 6 times a to the 5th power. Well, that's just 1 to the 5th power times b to the 1st. Well, b is 4x. So that's 4x to the 1st power. So what do I have there? I've only got 1x. That's not x squared. Keep going. Plus 15 times a to the 4th power. That's 1 to the 4th power plus b, which is 4x to the 2nd power. Wait a minute. X to the 2nd power. That's where I want to be. So now I'm just going to focus on that. I've got 15 times 1 to the 4th power times 4x to the 2nd power. 4x. I have to take both of them to the 2nd power. So that's 15 times 1 times 4 to the 2nd power is 16. X to the 2nd power is x to the 2nd. So I'm going to have 15 times 16. And 15 times 16, I believe, is 240. So that's 240 x squared. So that is my coefficient. Now, if it would have been when x is to the 6th power or something, I would have kept going till I got to x to the 6th power. See, the next one would have been b to the 3rd power. So that would have been 4x to the 3rd power. That would have been x to the 3rd power. The last one would have been 4x to the 6th power. So then that last one would have been if I needed x to the 6th power. Okay? So now we're going to do the next one. I'm going to erase and rewrite this because I need the 7th. So let's do this real quick. Okay. So that's 1, 1 and 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5 and 1, 1, 6, 15, 20, 15, 6 and 1. Now the 7th, this is where I'm at. 1, 7, 21, 35, 35, 21, 7 and 1. So that's where I'm looking at. So I want 1 a squared, whoops, not plus, sorry. Not a squared. What are you thinking, Ferg? Sorry, let's try it again. Let's do it in red too, so it'll be different. Okay, so I have 1 a to the 7th power b to the 0 plus, next is 7 a to the 6th power b to the 1st plus 21 a to the 5th power b to the 2nd power plus 35 a to the 4th power b to the 3rd power plus 35 a to the 3rd power b to the 4th. It's not a 9, that's a 4, plus 21 a to the 2nd power b to the 5th plus 7 a to the 1st power b to the 6th, and then plus 1 a to the 0 power b to the 7th power. So now I want c to the 4th, d to the 3rd. Well, honestly, I can look and think, okay, so my first term is 2c. My second term is 3d. I want the c to be to the 4th power, the d to be to the 3rd. So that should be right here. Because when a gets put, 2c puts right here, that's going to give me c to the 4th. And then right here, when 3d gets put into b, that's going to be 3d to the 3rd. That's going to be d to the 3rd. Now, if you, I guess I can just go through here, but that's where I'm going to end up. So I'm going to have 1 times 2c to the 7th power, and then b to the 0. So that's enough. So I'm going to have 7 times 2c to the 6th power times 3d to the 1st power. Well, that's only giving me 1d, so nope. 21 times 2c to the 5th power times 3d to the 2nd power. That's giving me 2d's. Nope. And here we go. 35, right? 35 times 2c to the 4th power times 3d to the 3rd power. So what's going to happen here? I'm going to have 35 times 2c to the 4th. Well, 2 to the 4th is 16. And then c to the 4th is c to the 4th. And now 3d to the 3rd. So that's times 3 to the 3rd is 27. And then d to the 3rd is d to the 3rd. Well, there's my c to the 4th, my d to the 3rd. So now I got to multiply this all out. Got my trusty calculator. So I'm going to say 35 times 16 times 27. That is 1,500. No, excuse me. That's 15,000. So sorry. 15,120 c to the 4th, d to the 3rd. I'm interested in the coefficient. So that's the coefficient, 15,120. And that's how you do it. Okay. Evaluate. Evaluate means I want the cosine of this. So first, if you don't want to use radians on your calculator, you can change this to you can change it to degrees. So let's see. If I want to change 5 pi over 6 to degrees, I want to multiply it times 180 over pi. Pi's cancel off. I've got 5 times 180 divided by 6. So 180 times 5, that's 900 divided by 6 is 150. So 5 pi over 6 is 150 degrees. So what is cosine of 150 degrees? Well, if you got your chart, you should just be able to look it up. It's right there. Okay. Cosine is the first value. It is negative square root of 3 over 2. Done. Now, if you don't have that, I know that, well, let's draw it out real quick. And let's erase this little positive b because it's all up in the way. So let's make a coordinate plane and let's do this really quickly. Okay. So I got my coordinate plane right here. And we said that it's 150. So let's put 150 right here. So that right there is 150. This right here will be my reference angle. So that's 30. Now this is the unit circle, so that means that's 1. If that's 1, what is this value? That's 1/2. And what is this value? This value, because it's on the left side, is negative square root of 3 over 2. And we're talking 150. We're talking about the reference angle's 30. So we're talking about cosine of 30. So cosine is the negative square root of 3 over 2 divided by 1. Negative square root of 3 over 2. See, remember over here, see, this is the negative side, right? And so that's why I'm saying cosine of 30 is my reference angle, and that's adjacent over hypotenuse. So let's see if I put this in my calculator like that. If I said trigonometry, cosine, and then I go up to degrees on my calculator and change it to radians. Okay, it's on radians on my calculator, and I'm going to put parenthesis 5. Let's see, where's the pi? Yep, there's pi. Divided by, so parentheses divided by 6. Yeah, it gives me some decimal, which is fine. It gives me negative 0.866025. Guess what that is? It's that. It's the square root of 3 over 2. There were a couple decimals that we wrote back in the day that, you know, the square root of 3 over 2 is 0.8660. And there were a couple more, but, you know, you get the picture. Use the chart. Give me the fraction. I don't want the decimal. Okay? So now let's go over here to sine of 7 pi over 3. Or excuse me, 7 pi over 4. 7 pi over 4 is 315. How'd I get this so fast? Because I got a chart right here. So let's do it the old-fashioned way. 7 pi over 4 times 180 over pi. The pi's cancel off. I'm going to do this the old-fashioned way. So I'm going to divide 4 by 4 and get 1. I'm going to divide 180 by 4 and get 45. And then I'm going to multiply 7 times 45. 7 times 5 is 35, so carry the 3. 7 times 4 is 28, plus 3, 29, 30, 31. It's 315. So 315 is right here. That's 315. My reference angle is going to be right here. So that's going to be 45. Now I want sine. Sine of this 45 is opposite over hypotenuse. When hypotenuse is positive 1. But that value right there is on the lower half, you know, of y. It's on the bottom, which means it's negative. So that right there is going to be negative square root of 2 over 2. Because my reference angle is 45, I know it's just going to be square root of 2 over 2. The question is it going to be positive or negative? Well, it's in the fourth quadrant. Fourth quadrant, sine is negative, cosine is positive. So bada boom. All right, let's see what else we got, because I got to get ready to go get my children's, so I don't got much more time. Okay, calculate the reference angle. 4 pi over 3. 4 pi over 3, that is 240. How to get it so fast? Chart. So let's do it the old-fashioned way. Over 3 times 180 over pi. Pi's cancel off. So I divide the top, the bottom and the top by 3. That's 1. That's 60. 4 times 60 is 240. So 240, where's that at? 240 is right here. That's 240. So what's left? Because this is 270. I want this triangle right here. Well, if it's in the third quadrant, I take 240 and minus 180. So what do I get? I want this one right here. So this angle right here is 60 degrees. So 60 is my reference angle. See, this whole thing right here is 270. So if I was looking at this triangle, I'm looking at the 30, but that's not where I'm going. Remember what happens. This is pi, or this is theta, excuse me. This is 180 minus theta for your reference angle. Third quadrant is theta minus 180. And in the last quadrant, the fourth quadrant, is 360 minus theta. Remember, theta is just a variable that we use for your angles. So let me write this a little plainer so you can see it. Okay, when I'm determining reference angles, I think about what quadrant we're in. If we're in the first quadrant, it's just the angle because a reference angle is between 0 and 90. If it's in the second quadrant, I take 180 and subtract the angle from it. That gives me the reference angle. Like for instance, if I was, I think we just did 150, right? So 180 minus 150 is 30. So my reference angle is 30. Well, what about this one? That is theta minus 180. That's if you're in the third quadrant. So the third quadrant, well, this one's 240. 240 minus 180, that's 60. Boom, that's my reference angle. And then finally, if I'm in the fourth quadrant, it's 360 minus theta. So like, for instance, the one we just had a minute ago was what, 315? So 360 minus 315 is 45. That's my reference angle, 45. So 11 over 6. What is 11 over 6? 11 over 6 is 330. Don't need to tell you how I found it so fast. So 11 pi over 6 times 180 over pi. Pi's cancel off. 6 divided by 6 is 1. 180 divided by 6 is 30. 11 times 30 is 330. So what's my reference angle? It's in the fourth quadrant. That's 30 degrees. Boom. Now, this is something that we just did. I need to think of two values, radians, that when I add or subtract them, I get pi over 12. Well, that's pretty simple. It's 4 pi over 12 minus 3 pi over 12. Now, why did I choose those? Because they reduce to something that I know we've been doing. They reduce to pi over 3 minus pi over 4. Now, you could say 3 pi over 12 minus 2 pi over 12. That reduces to pi over 3 minus pi over 6. Nope, sorry. That's pi over 4. So pi over 4 minus pi over 6. Now, why did I do this? Well, pi over 3 is 60 degrees. Pi over 4 is 45 degrees. Pi over 6 is 30 degrees. So see, we've been doing those. We've been using reference angles and finding 60, 45, 30. We've been doing that. So that's why we're taking this and we're putting it in that format, right? And you ain't getting extra credit if you do it fully. You need to do it fully. So you need to know the identities for sine minus and plus and cosine minus and plus. So this is going to be sine of alpha minus beta. Sine of alpha minus beta. So I'm going to, where did I write my identities at? Okay. So, you know what? I got sine of plus. I don't have sine of minus. So let's cheat and find sine of minus. Sine of a minus v identity. Really, you gonna do all this? I just wanted that. Okay, y'all give me a whole lot of gobbledygook. Yeah, don't use Bing, use Google. Let's try that again. Sine of a minus b. There we go. So what do I got? I've got sine a times cosine b minus cosine a of sine b. Okay, so let's do that real quick. Okay, so let's do that. So sine of a minus, okay, so that's sine of a minus b, right? And that equals sine of a times cosine of b minus cosine of a times sine of b. So what does that mean for this? Depending on which one I use, I'm just going to use this one because that's pretty much the one we've been using forever. So I'm going to have sine of pi, well, okay, fine. Let's do it right. So I'm going to have sine of pi over 3 minus pi over 4. So a is pi over 3, b is pi over 4. So I'm going to have sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. So pi over 3 is 60 degrees. So give myself 60 degrees and give myself my unit circle. 1/2. Because that's 30. That's a 30, 60, 90. So sine of 60 degrees, that is opposite over hypotenuse. So that's going to be the square root of 3 over 2. Cosine of pi over 4, well, that's really simple. 45 degrees, that's 1. This is square root of 2 over 2, and this is square root of 2 over 2. So that's pretty simple. So that's square root of 3 over 2 times square root of 2 over 2 minus, and then I've got cosine of pi over 3, or cosine of 60. Cosine of 60 is adjacent over hypotenuse. So that's 1/2 times sine of 45 degrees, or pi over 4, that's square root of 2 over 2. So now I just multiply. 3 times 2 is 6. So that's square root of 6. 2 times 2 is 4 minus 1 times square root of 2 is square root of 2 over 2 times 2 is 4. So it's either that or you can just write it as 1 numerator over 4. So either one of those. I saw somebody where they had these two and they said 5 because they said 3 plus 2. That's times. So it's 3 times 2. They're both under the square root, so you can multiply them. All right, finding the inverses. So this is the last thing I can do, and then I got to take a pause. Okay, so inverses. I'm going to change my f of x to y. So I got y equals 1/2 x minus 5. I'm simply changing this to where I isolate x. So first thing I'm going to do is add 5 to both sides. So y plus 5 equals 1/2 x. I don't want 1/2 x, I want x. So I got to get rid of 1/2. This is 1/2 times x. So what's the inverse operation of 1/2? It's multiplying by 2. So I'm going to multiply both sides by 2. If I take 1/2 x and multiply it by 2, and I take 2 times y plus 5. All right, so that's going to be 2y plus 10 equals x. That is my inverse. All right, and I'm got to stop right there because my wife is calling me.